So, you thought unpredictability in fractals was all there was to chaos theory. Not even close. Chaos arises in the stupidest places. Something as simple as predicting when the next eclipse will be turns out to be mega complicated, even though we are pretty good at it. Here's the deal. If the Earth, the Moon, and the Sun were all basically the same size, it would be completely unpredictable what would happen. This is known as three-body problem. Fortunately, the Sun is insanely bigger than the Earth, and the Moon isn't really a satellite, it's more like an Earth extension. You know why we always see the same side, right? Okay, that's a lecture for another time. So, if we treat the Earth and the Moon as a point compared to the Sun, we can predict the Earth's orbit very well. Then we can treat the Moon's orbit around the Earth by treating the Sun as a constant. And so we can reasonably predict solar and lunar eclipses. There's a similar problem at a much smaller scale known as the Heisenberg uncertainty principle. Basically, it means you can't know the mass, velocity, and position of a particle at any one time. Actually, Wikipedia describes it as position of momentum, which is very similar. This is why we have quantum mechanics in the first place. And this is one of the things that drove Einstein crazy. Where was I going with this? Oh yeah, so my point is that when you are dealing with two things, typically they are pretty simple. But when you introduce a third thing, it has the potential to be completely unpredictable. Now consider this picture. This is an example of a system going from stable to chaotic as you move to the right. But note that about 90% of the way across, there's an island of stability. And the period is 3. What's important about this is the entire graph is generated by things splitting in two. That is, it goes from 1 to 2 to 4 to 8, and then to chaotic. There's never any 3 introduced anywhere. If you know anything about remainder or group theory, you know that 3 doesn't come from 2's. In fact, there's something called Sharkovsky's theorem that proves that if you see a period 3, the thing is chaotic. So what does this mean to me? Well, maybe you haven't noticed, but a lot of things in nature have a period of 3. Yes, I know it's a Fibonacci number, but it's also indicative of chaos. That's right, life is chaotic. But you knew that already, didn't you? Just to prove my point, did you know that protons, neutrons, electrons, photons, and even quarks have a spin of 1/2? What's spin, you say? Well, it's basically a measure of isometry. That's a whole other topic on itself, but basically it means that when you spin the particle around, if it has a spin of 1, it won't look the same until you spin it around 1 complete rotation. If it has a spin of 2, it only takes half a rotation to look the same. If the spin is a half, that means it takes a spin of 720 degrees to look the same. Huh? That's right. All the basic particles that make up everything we see, feel, and touch is made up of little tiny Mobius strips. Okay, I'm oversimplifying, but the point is the universe is weird, and so it should not surprise you that 3 means chaos.